Hi, it's good to see you again. We're going to talk about the SI system. It's called the System International, French, and it talks about how, if you look at the signpost right here, you see numbers here. What the heck these numbers mean? Are they miles or are they meters, kilometers? What the heck are we doing here? So whenever we have a number in chemistry, we have to talk about what the unit is. Is this a mile or is this a kilometer? We need to use that. So we're going to do that always. We're going to have a number in a unit when we talk about chemistry. So there's 5 base units in SI, and these are the ones that we normally use in chemistry. All of these are units that serve as reference standards, and so it comes from this French name, the Système International, if I'm saying that right. So we call it the SI for short because I can't generally say that very well. So here's the things that we use in chemistry. We use a meter. We do everything in metric, so this is like a metric system. And it is a lot easier on the math. So we use meters for length. We use kilograms for mass. We use Kelvin for temperature, second for time, and the mole is how much we have of a particular element. So we have to get used to all of these words. So these are the units that we normally use that I just said. And we do everything in metric, so everything's based on 10. And it makes our lives so much easier. We're going to have to know a lot of these. You're going to have to know these. I'll tell you exactly what we need to have memorized. Kilo, we need to know that means 1,000. Deci is 1/10. Centi is 1/100. Milli is 1/1000. Those ones we have to know. We have to have those memorized. So we'll work on this in this class. And so here's some examples of what these things are in real life. Like a kilometer is kind of like 5 city blocks. Centimeters, a shirt button that you have on your shirt. So that gives you an idea of what these things are looking like. So volumes, we use metric meters. And we use something called a liter. So you're used to liters, like a 2-liter bottle. There's 2 of these things together. So we use liters a lot in this class. And it has a physical measurement. It's like you can measure 10 by 10 by 10 centimeters, and you get 1,000 cubic meters, which is 1 liter. And here's some examples of a liter's close to what a quart of milk would look like. Okay, so we're going to use all of these in this class. And here's what 20 drops of a liquid like water would equal 1 milliliter. So we're going to use milliliters a lot in the lab. And 1 cubic centimeter looks like this. 1 times 1 times 1. Sugar cube is about what 1 milliliter looks like. Those 5 drops we were just talking about. Or sorry, let me go back. The 20 drops is 1 milliliter. So that's the same as this volume of a sugar cube. That's 1 milliliter, or 1 cubic centimeter. So these things are equal to each other. I usually have this on the final exam. 1 milliliter is equal to 1 cubic centimeter. We'll get used to that. And you know a 2-liter bottle has 2 liters in it. So that's the volume of a liter. We use mass, we use kilogram. And 1 gram is the mass of 1 cubic centimeter, so they're equivalent to each other. So that volume of sugar cube, if you had that in water, it would be 1 gram. So here's some examples of things so you get the idea of what these weights are like. A textbook would be, a smaller textbook would be 1 kilogram. A dollar bill is 1 gram. And weight is different than mass, so we use mass in this class because we use balances to find the mass. It's the amount of stuff you have. Weight is the gravitational pull of wherever you're at. So on the moon you'd have a different weight, but you'd have the same mass as you have on Earth. So temperature is how hot or cold something is, and we're going to use thermometers in this class. We're generally going to use Celsius measurements in this class. Not in America we use Fahrenheit for temperature, but we're going to use Celsius in chemistry. We also use this thing called Kelvin when we get to gas laws. So this is important. Freezing point of water is 0 to make ice. And when we boil water, it's at 100 degrees Celsius. So these are things to know. And Kelvin is also something we'll use later on in class. We add this number to all of our Celsius numbers to get to Kelvin. And there's a thing called absolute zero where no atoms or molecules are moving, and that's called absolute zero. So we use this scale when we do math for gas laws. So this is the equivalency of those two things, and we'll get used to this a lot. When we have to find out Kelvin, we're going to take the number we know for Celsius and just add 273 to it, and we'll get to Kelvin. So this is just showing how they're equivalent to each other, how they stack up against each other. So for Celsius, it's 0 degrees for freezing, 100 degrees for boiling, and then it's going to be different numbers for Kelvin. So let's try an example. So let's say you know that your temperature in Celsius is 37. What would that be in Kelvin? So we're just going to add 273 to it to get to Kelvin. So we're going to take the number we knew at the beginning for our temperature and add this 273, and we'll get to what our temperature would be in this scale. So energy is a different thing. It has to do with how much work you can produce or how much heat you can produce. That's energy, and we use energy in chemistry as well. Lots of chemical reactions produce energy or take energy to happen. And we use something called the joule or the calorie, and we're going to use these a lot in this class, joule or calorie, to figure out how much energy a chemical reaction has. And so they're related to each other by, I usually remember this one. 1 calorie is 4.184 joules. And sometimes we have to go back and forth between these two scales. So this is a good thing to know. So let's try our quiz. Let's see how you do. Okay, good luck. Which is not an SI unit? I might not remember. Let's see what it is. So gram, remember it has to be kilogram when we're talking about the base units. In chemistry though, we don't measure big things like that, like the size of a book. We use smaller things, so we have to use grams for chemistry. So you measure both the mass and weight on Earth and on the moon. What would you find out? So the mass stays the same, the amount of stuff in your body stays the same, but the weight, depending on what the gravity is, will change. So that makes your weight change. Okay, last question. If you have 30 degrees in Celsius, what's it going to be in K? So how do you do that? Do you remember? You're going to add 273 to that 30. So what would you get? Yay, you get 3 of 3. So I hope you got a lot out of this little presentation, and this is really important. We're going to use all this information a lot in this class. So good luck. I'll talk to you soon. Bye-bye.